Hello everyone! Today we will explore the electronic components used in mechatronics and understand how the small parts help create smart machines, robots, and automated systems. But before we continue with our discussion, let us first define what is mechatronics. Mechatronics is a field that combines electronics, mechanics, and computer technology to create intelligent machines. Behind every robot and automated system are electronic components that allow machines to sense, process information, and perform actions. The first component on our list is the resistor. It controls the amount of current flowing in a circuit. It protects sensitive components from receiving too much electricity. Examples: Arduino robot. A resistor limits current going to LEDs so the lights do not burn out. Robot sensors. Resistors help control the electrical signals received by the sensors. Next, we have the variable resistor or the potentiometer. It is a type of resistor that can be adjusted manually. It allows users to control movement, speed, or position in a mechatronic system. Examples: the robot arm. It adjusts the position of the arm by changing resistance. Robot controller. It is used in joysticks to control direction and movement. Capacitor. A capacitor stores energy and releases it when it's needed. It helps prevent sudden changes in power that may affect a machine. Example: motor driver. It provides extra energy during motor startup. A robot power system. It keeps the voltage stable when motors suddenly require more power. An inductor. An inductor stores energy using a magnetic field and removes unwanted electrical noise. Examples are the power converter. It provides stable power to electronic circuits, and robot motor controller as it helps motors run smoothly. Diode. A diode works like a one-way gate for electricity. It prevents reverse current that can damage components. Example: power supply. It prevents incorrect current flow. Robot motor. It protects the controller when the motor suddenly stops. LED. LEDs produce light using electrical energy. In mechatronics, they are used to show machine status. Examples: robot. It indicates if the system is powered or active. In control panel, it shows warnings or operating conditions. Next, a transistor. A transistor works as a very fast electronic switch. It controls when components turn on and off. Examples: robot car. It controls the motor movement. In an automatic fan system, it turns motors based on sensor signals. Integrated circuit or IC. An IC contains many tiny electronic parts inside one chip. It acts as the brain of many electronic systems. Examples: Arduino robot. It processes sensor data and control movements. Switch. A switch controls whether electricity flows or stops. Example: emergency stop. It quickly stops machines for safety. Relay. A relay allows small control signals to operate a larger electrical device. Example: conveyor belt. It turns motors on and off automatically. Transformer. A transformer adjusts voltage so machines receive the correct amount of electrical power. Example: factory automation. It supplies proper voltage to control system. Now, a fuse. A fuse protects circuits by stopping electricity when the current becomes too high. Example: industrial equipment. It protects expensive components. Hopping on to circuit breaker. A circuit breaker protects machine by cutting off electricity when too much current flows. In factory control panels, it protects automation equipment from electrical problems. Battery. A battery provides the energy needed for machines to operate without being connected to a power outlet. In mobile robots, it powers the motors, sensors, and controller that allow the robot to move. In drones, it supplies power to the motors and flight systems. Power supply. A power supply converts electricity from an outlet into the correct voltage needed by electronic components. In PLC systems, it supplies energy for automated machines in factories. Breadboard. A breadboard allows engineers and students to test electronic circuits without permanently connecting the ports. In Arduino robots, it is used to connect sensors, LEDs, and motors before creating the final circuit. PCB or the printed circuit board. A PCB is the main board where electronic components are placed and connected. In drones, it connects parts responsible for movement and stability. Jumper wires. A jumper wires connect electronic components during testing. In Arduino robots, they connect sensors and motors to the controller so that the robot can receive information and perform actions. Hopping on to LDR, or the Light Dependent Resistor. The LDR detects changes in light by changing its resistance. In light sensing robots, it helps the robot identify the direction of light. Next, the thermistor. A thermistor detects temperature changes and sends information to the controller. In 3D printers, it monitors the nozzle temperature to keep it accurate. Buzzer. A buzzer converts electrical signals into sound. In factories, it warns operators about machine errors or safety concerns. Next on our list, we have our servo motor. A servo motor is designed for precise control of position and angle. Unlike a regular motor, it moves accurately to a specific position. In mechatronics, servo motors are used in robotic arms, drone, and automated machines that require accurate movement. Stepper motor. A stepper motor rotates a small, precise step instead of continuous motion. This allows accurate positioning without losing control. In mechatronics, stepper motors are used in CNC machines, 3D printers, and robotic positioning system. Microcontroller. It is often called as the brain of a mechatronic system. It receives information from sensors, processes the data, and sends commands to output devices like motors, LEDs, and relays. In mechatronics, microcontrollers such as Arduino and ESP32 are used in robots, smart home devices, and automated machines to control how the entire system works. And last but not the least of our components on our list, we have the DC motor. A DC motor converts electrical energy into mechanical movement. In robot cars, it rotates the wheels to allow movement.